Hi guys, in today's experiment we're going to be looking at a fairly exciting chemical reaction between potassium permanganate and glycerol. Now often this would be sort of a high school level experiment, but I firmly believe that this is one that we can do quite safely at primary school as long as we take the correct precautions. So things that you'll need in terms of safety, you should be wearing safety goggles whenever you're performing this. A blast screen to protect your class is highly recommended, and because it is an oxidative or fiery reaction, it's a good idea to just have a fire extinguisher on standby as well, and possibly even a fire blanket. Essential is a ceramic or any sort of heat-proof mat as well. Now, in terms of learning outcomes, this is one that covers a couple of different things. So any sequence, lesson sequence that you're doing that is focusing on just chemical reactions in general, this is quite a good one. It's one that shows several of the signs of a chemical reaction. We get a little bit of fizzing to start off with. We get the production of heat and light, all of which are good signs of a chemical reaction. We get the obvious production of a gas as well, which is a separate product from the reaction. So all of those are obvious signs of a chemical reaction taking place. And in terms of an actual lesson, you can get the kids to note down anything they see, obviously, that indicates a chemical reaction is taking place. And it's far more engaging and let's say, aesthetically pleasing than your standard vinegar and bicarbonate soda stuff that we often do at primary school to death. In terms of other learning outcomes, though, there's quite a lot to do with energy. This is a highly energetic reaction. So we're generally fairly good at telling kids about heat energy, about light energy, about kinetic energy, and we often do all that whenever we're covering anything to do with forces and so on. But what we don't often focus on is chemical energy and how that chemical energy can be transformed into other forms of energy like heat and light that can then do useful work. So, chemical energy is what fuels the vast majority of our energy production and our energy needs across the world through power plants. Whether or not that's a good thing or a bad thing, definitely a bad thing, that's a discussion for another time. But what we have here are some chemicals that have chemical energy locked up inside them. We can release some of that energy and transform it into different kinds of energy, such as heat and light. And that's what this experiment is going to do. Now, we're going to start off by taking some potassium permanganate, and we're going to pop it in this tray here. Okay, I'm going to take probably a couple of spoonfuls, no more than sort of 10-15 grams at the most, probably even less than that. But a couple of these spoonfuls here. Now, it's a very good idea to wear gloves for this, because this can stay in your hands. And it is not the most environmentally friendly of substances, and we're going to talk about disposal of this at the end of the video. Now, once I've set this out using the spatula, I'm going to create a small depression in the middle, so it's almost like I've got a miniature volcano. So I'm just going to create a hole in the middle here, and that is going to be where I'm going to put the glycerol. Okay? Now the glycerol or glycerin, same thing, that's really where the source of the chemical energy is. So that's basically what we're oxidizing, what we're igniting, what we're setting fire to. Now I'm going to move anything else that's flammable out the way at this point, including my phone, because I don't want that to have any damage done to it. And now what I'm going to do is I'm going to just pour a small amount, just a few drops of the glycerol into the middle of this depression here, and I'm then going to stand behind the blast screen, and you'll see what happens. A little bit here. I'll step behind. I'll bring the camera up so we can see. So straight away, we've got the production of a gas there. And that alone will probably capture the kids' interest, but very quickly, we get this quite impressive sort of purpley lilac flame coming off. So we have the production of heat and the production of light there, and we can see the gases coming off too.
Now this doesn't need to be done in a fume hood. If you have a fume hood, excellent, but it's not required to be done in a fume hood. The majority of the gas there is just carbon dioxide, some trace amounts of other chemicals as well, but generally pretty safe. So fairly energetic, fairly visually engaging, and the kids absolutely love it. Now this burns with a very high heat, so that's probably the most important thing to bear in mind right from the start there. It's very, very hot, so I would not be touching this for quite a while. That needs to cool down quite significantly. When I do decide to touch it again, I need to be positive that the reaction has finished. So I'm going to, using a spatula or some other metal implement, make sure that I mix up the chemicals, stand back from it again, let anything else react that might be waiting to react. And when I'm absolutely positive that the reaction has finished, I can dispose of it in a couple of different ways. The best way is to develop a good relationship with your local high school, get in touch with the chemistry teachers up there, get to know the lab technicians, and they will advise you on how to transport this up there. You can dilute, another way of disposing of it is to dilute 5 grams of this in 2 litres of water. So if I've used 15 grams, I would have to use 6 litres of water. Now that's not a small amount of water. So every 5 grams in 2 litres of water, mix it in, make sure that it's not reacting, and then it can go down the sink. Now, it is important to note that potassium permanganate is highly toxic to aquatic life in larger quantities. In smaller quantities, in the kind of as a one-off experiment done very infrequently, in the sort of quantities that we're dealing with in school, this very small amount, it would be acceptable to dispose of it in that way. I'll link to a couple of pages that advise on how to dispose of this appropriately. But there you go. Visually appealing experiment, gets the kids very excited, and definitely worth doing at primary level. Cheers.